right now is fairly higher.
All right. Today we're going to look at section 5-7, roots and zeros. Okay, so we're going to start with a couple of quadratics, things that we dealt with last unit. We've already tested on these. These shouldn't be any sort of stretch at all, but just kind of as a lead-in or a tie-in to some other polynomials, but quadratics would be are polynomials as well, so they fit into this. But so we need to go ahead and solve. It looks like this one is factorable. So I would probably go ahead and factor it. So we get x plus 2 and x minus 5. Those are the factors. And then to finish solving, set each factor equal to 0. Solve them both, and we get -2 and we get +5. So those are our solutions, but the instructions also state, they state the number and type of roots. So we had 2 answers there, so there's 2 roots. And really, all we need to do is specify like real versus imaginary. So we see that they're both real. So to answer that second part of the question, I would say there are 2 real roots. What was the degree of that polynomial? 2. How many roots were there? 2. Coincidence? Let's take a look at another one. We have another quadratic here, x squared plus 4x plus 4. It is factorable. But when we factor this, we get the same factor twice. X plus 2 times x plus 2, or x plus 2 squared. So we only have one unique factor. So we know that that unique factor has to equal 0. So we get an answer of -2. What was the degree? 2. How many answers would I expect? 2. How many answers did I get? 1. What's the disconnect? That factor happened twice, did it not? So it's like that 0 kind of happened twice. Now, if we think of a graph and you think about the zeros, the x-intercepts, what did the graph look like when you had 1, 0? When it was a parabola, this is a parabola. When it's a parabola with 1, 0, what's true about that graph? Understanding that connection would be helpful. Yeah, the vertex was the x-intercept, and so it only touched the x-axis once, not twice. So your graph did not pass through the axis. It touched it, and I like to use the word bounce. It bounced back off. Didn't actually cross through. So we only had one x-intercept. So our answer here about the number and type, there was only one real root. Whoops. Trying to combine words here, I guess. There we go. One real root. But we do have a name for that kind of root where it happened twice. We will call it a double root. That way we understand that's why we didn't have the 2. We expected 2, we only got 1, but it was a double root, it counted twice. So that kind of satisfies us. At some classes, and you know, pre-calc is probably the same way. Instead of saying double root, they'll use multiplicity. So they would say the multiplicity is 2. You could have roots that happen more than twice even. You could have extra, or you know, a third root or a fourth root, and their multiplicities would be higher. So that's consistent with what you'll see then as well. Yes, question? Oh, I just sketched wrong. Yeah, sorry, good point. It would have been over there. I wasn't really thinking about what I was sketching. Yep, it would have been over there somewhere. Sorry about that. My x was a my root was a -2. That's why it should have been on the left side. Let's take a look at another one, but one that's not quadratic. So this one's not quadratic, but as we consider trying to factor this, hopefully you realize that, oh, I do have an x in every one of those every one of the terms. I could factor the x out. Don't divide both sides by x. If you divide by x and you lose one, you just lost one of your answers. That's not what you're looking for. But if you can divide them all by x, then factor the x out. Leave it there, don't lose it. End up with x squared plus 12x plus 32. And now what's in the parentheses is quadratic, so we can factor it like the other ones. Looks like we get an 8 and a 4. They multiply to 32, they add to 12. Set every factor equal to 0, and please do not neglect the x. That x is a factor. There's no parentheses around it because it's like an x plus 0 or an x minus 0, but it is a factor. We have 1, 2, 3 factors. Set each one of them equal to 0. How many answers am I expecting to get? 3. There's 1. We get -4, and we get -8. I did, in fact, get 3, and they're all real. So those are convenient and all, but are we always going to get real roots? No, so let's take a look at another. (16x to the 4th minus 81 equals 0). Let's factor that. It is a difference of 2 squares. Goes to 4x squared plus 9, 4x squared minus 9. Notice that second factor, the 4x squared minus 9, actually can factor again because it's also a difference of 2 squares. I can go to 2x plus 3 and 2x minus 3. But 4x squared plus 9 does not. It's not a difference, so I can't do that. Set every factor equal to 0 now. Solve them each. The 4x squared plus 9 isn't going to work out as nice. So we have to subtract the 9 over and then divide by 4. So I've got this fraction, and now I have to square root. And when you square root, you have to do plus minus. So there's 2 answers there, not just one. Plus minus, square root of negative 9/4. Break the numerator and denominator apart from each other. Think about the numerator first. Square root of negative 9. 3i over square root of 4, 2. How many answers are represented right there? There are 2 answers represented there because of the plus minus. So we said x equals a positive 3i over 2 and a negative 3i over 2. So that is 2 different answers plus the 2 I already gave. I was expecting 4 answers. I got 4 answers. Are they all real though? No. How many real? And then 2 imaginary roots. I do want to point something out to you. To get an imaginary root means that we square rooted a negative number. If you introduced a square root, then we also have to have a plus minus. Every time you have an imaginary root, they must come in pairs. So every time you introduce an I, there's a plus minus involved. You will never have an odd number of imaginary roots. They will always be in pairs. You could have more than 2. You could have 4 or 6 or 8, but they have to come in pairs. Okay, so that's one type of problem. That's the roots piece of this. The title of this section was roots and zeros. So now let's transition into talking about zeros. There's a very close connection between roots and zeros, but they're not quite the same thing. What's the difference? What is a zero? Zeros are x-intercepts. So we're graphing. Roots are answers to solutions to the equation. Zeros are x-intercept. Is there a connection between them? Yes, there is. Are they the exact same thing? No. What's the difference? Think about that last problem we just had there. How many roots did we have in this last example? 4 roots. How many zeros would it have? It would only have 2 zeros. Why are there only 2 zeros? Do the imaginary roots show up on your graph? No, as x-intercepts? No, only the real ones show up as zeros. So sometimes there's a little disconnect between roots and zeros. Just want to make sure you understand that. Okay, so the next type of problem I want to talk about. Find all of the zeros of the function. All right, we'll start over with number 1. F of x is equal to x cubed plus 9x squared plus 6x minus 16. So we want to find zeros. Can factors be helpful in finding the roots, be helpful to us in finding the zeros? Absolutely. So if we can factor this, that is helpful. But as you look at this problem, we see it has 4 terms. And we have talked about factoring by grouping, but I don't believe any of our groupings are going to work on this one. So then we're kind of stuck. What do we do? And there's an answer on how you could proceed, but that comes in the next section, which we're not even going to teach. We're saving it for pre-calculus. So if you take pre-calculus, you will learn how you can find them on your own. What we're going to do is we're going to do a little bit of cheating. We're going to look at the graphs and let the graph help answer our question. So I've got this already graphed on Desmos. Let me switch over. Oops, wrong window. Try again. Desmos right here. Okay, so I have this same function graph. I think that's the same one, right? x to the third plus 9x squared plus 6x minus 6. Yeah, the first one up here. And we're talking about zeros, which are x-intercepts. So I'm going to click on this one right there, and I see that it's 1. Yeah? So let me go back. I cheated a little bit to get a head start. So find all of the zeros. Maybe down here somewhere I'm going to list my zeros. One of them I know is 1. If we connect this with the last section, can't I divide out a factor? If I have a 0 of 1, what factor do I have? What's its factor? If you have a 0 of 1, what is the associated factor? The factor that goes with it? X minus 1, yeah. It's like the opposite of what I was just doing up here. I set factor is equal to 0 to solve. So what can I do? Can't I then, if that's a factor, can't I divide this by x minus 1? Can't I factor that out? Then I can do synthetic division for that. So we're going to use synthetic division. What number goes in the box? The positive one, the 0. If the factor is x minus 1, you switch the sign from the factor. The 0 is what goes in the box. Drop your first number down times the number of the box. Add and repeat. And we get a remainder of 0, which was necessary. That's good. At that point, I just factored out x minus 1. When I factored out x minus 1, what was I left with? Well, those coefficients on the bottom give you what you're left with. X squared plus 10x plus 16. Your remainder is 0, so I ignore that. That's a quadratic. That's something we're more familiar with. Is that one factorable? Yes. So let's factor that down. Don't forget the x minus 1 that I already pulled out. Yep, we have a 2 and an 8. So what are all of my zeros? I already started my list over here. -2, we have switch signs, and -8. How many zeros did I expect? 3, because I had a degree of 3, and I found them all. So if the fact, because to go from factors to zeros, so if we had x minus 1, we knew the factor was 1. If we have a factor of x plus 2, what you're doing is setting x plus 2 equal to 0, solving, you get -2. If you have a factor of x plus 8, set equal to 0 and solve, you get -8. Yes. What's that? How is that what? How is that different from roots? It's not in this case. Because the roots were all real, they are the same thing as the zeros, yes. How did I get the 1? I cheated, and I looked at the graph of the function, and I saw what what one of them was. What was to stop me from hitting this and seeing all of the answers? Couldn't I have just done that? Sure, I could have. But you won't be able to do that. There's some workarounds where you can't just rely on that. But here's a good reason why we can't just do that. If you want to know why you can't just do that, it's not going to completely help us solve the next problem. Same set of instructions, but now let's look at f of x equals 3x to the 5th minus 8x to the 3rd plus 2x minus 4. That one is not factorable by grouping either. Although I did not give you the problem I meant to give you, because when I switch over to decimals, that's not what I put in there. I looked at the wrong problem, so I'm going to erase that one. Not that we couldn't do it, but then I'd have to go change it in decimals. So we're going to not do that one. They are not giving you a factor or a 0 in this section. So you will maybe need to do some graphing to get started. Okay, this is the one I meant to give us. How many zeros do I expect on this one? 4, great. This is a 5-term polynomial. We have not we have not factored any 5-term polynomials. Some of them can be factored. Maybe this one can. You can do grouping, not like in the same way we've done grouping. You can actually do a 2 by 3 grouping. We are not going to do that. Don't worry about that now. We're going to cheat. So I know some of you are still writing. Here, it's the bottom one. You will be fine on the test. We'll talk about that more later. Don't worry about that just yet. Don't worry about yet what it's going to look like on the test. Okay, so here is, if you didn't get a copy down, because I know we didn't stay on that last screen very long, it's the bottom equation off to the left. X to the 4th minus 2x cubed minus 8x squared minus 32x minus 384. Okay, I had to zoom out a ways, stretch, whatever, but we see the picture. How many zeros did I expect? How many did I expect? I expected 4 zeros. Do I have 4 zeros? I have 2. Do I need to change my zoom? Is that the problem? No, this one doesn't quite work out. Okay, I still want to know a 0. Guess what? I'm going to cheat on both. I have 2 of them. Let's find them both. I don't know why that -2 0 there. That's gonna. Okay, so there's 2 zeros, 6 and -4. Okay, so I'm cheating twice. Let's go back now. Now that I know 6 and -4. Yep. It's going to make our life a little bit easier if I just use both of them. 6 and -4, correct? I believe, I hope. So we're going to do synthetic division. 1, -2. And why are we doing synthetic division? Did I find all of my answers on Desmos? How many answers are there? I'm looking for 4. I would be looking for 4 roots, right? I would be looking for 4 roots. I only saw 2 zeros, but I do want to go ahead and find the imaginary ones as well. They didn't show up on there, but we are going to go ahead and find them. So we can't find that on the graph. That's why we have to do this process. So we're going to do synthetic division. What can I divide by? 6. Take one of the zeros that I had. Doesn't matter which one's first. Pick one of them. Let's run our synthetic division. And it gives us that. Fantastic, that's nice. But I want to divide out another one now. So I'm going to, instead of rewriting the problem, I'm going to do another synthetic division. Right from there, I'm going to leave those numbers written there. And I'm going to put -4 off to the side, because I haven't divided by that one yet. And I'm going to divide that one. Nope, now I'm using my new numbers. So I knew 2 zeros, so I synthetically divided them both out. When 6 was a 0, x minus 6 was a factor. When -4 was a 0, x plus 4 was a factor. When I pulled both of those out, I was left with, yep, remember I've divided twice now. I started the problem with an x to the 4th, but I've divided twice now, so my degree has gone down by 2. So now I'm down to x squared. 1x squared, then it'd be 0x. I don't have to write that. Then a positive 16 is my constant. Okay, so that's the factorization of this polynomial. We set each factor equal to 0. I've already got the first 2 taken care of. I already know the 6, and I know the -4. It's the rest of it that I'm more interested in. So I had x squared plus 16, set that equal to 0, solve that. So I would subtract the 16, then I square root, and don't forget plus or minus because I square rooted, plus and minus 4i. There were 2 real roots, but we also had 2 imaginary. The graph did not give that to us. So we can't just rely on a graph to give us all the answers because it won't give you the imaginary ones. One last type of problem I should discuss quickly. It's really kind of the opposite of that. Write a polynomial. Write a polynomial function of least degree with integral coefficients. Oops. With integral coefficients that have the following zeros. -2, 5, -3i. So it gives us the zeros, and we have to give the function. So we have to turn these zeros into factors. But first of all, what is missing in this particular problem? There is one more zero in this problem that I have not given you that you should recognize and include. What would that be, Emma? +3i. We know that imaginaries always come in pairs. They always come in pairs, and really they're just the conjugates of the other one. So if you had 1 + 2i, you would know what would be 1 - 2i. And in this case, it was -3i, so we know it's +3i. That would be an additional one that they didn't give us. So now let's write them as factors. -2 written as a factor is x plus 2. 5, when I turn it into a factor, is going to be x minus 5. What's the -3i going to turn into? X plus 3i. And then the 3i, it didn't give me that, but I knew it needed to be there, is x minus 3i as factors. We need to multiply this out. Please, please, please save yourself tons and tons of work and multiply the 2 imaginary ones together. Regardless of what else you have, at least multiply those 2 together. Don't try to distribute one of those into a different one. That will cause you some problems. Okay, when I FOIL that out, I get x squared, a -3ix, a +3ix, and then a -9i squared. So when I simplify that down, the -3ix and the +3ix will cancel each other out. And -i squared, what does that equal to? +9. Remember, I squared is equal to -1. Remember that rule. I squared is defined as -1, so it's -9 times -1, +9. Okay, so when I multiply those together, I got x squared plus 9. That's great. Let's go ahead and maybe just FOIL the other two together. X squared, meant to go the other order, but I'll go with my positive 2x, then my minus 5x, and then -10. So that's x squared minus 3x minus 10. And now I need to multiply those together. Remember our multiplication of polynomials that we just did recently?
Yeah.
Here we go. X to the 4th plus 9x squared minus 3x cubed minus 27x minus 10x squared minus 90. I do want to combine any coefficients and put it in descending order, or combine like terms, I meant to say. Okay, so I got that one done. I got that one done. My x squareds, I have 9 minus 10, so that's -1 x squared. And then I have a -27x minus 90. The problem said that we should have integer coefficients. Do I have that? Yes. Do I know if there was an a value? I don't know. You don't need to put one in. If you want to put one in, just make sure you distribute it throughout. You could throw a 2 in there and multiply everything by 2, but that's just extra work you don't need to do. But there's an example of a function that had the given zeros. In all its beauty.